Hello Year 10, so today we're looking again at electromagnetic waves, and in particular UV waves, X-rays and gamma waves. So again, here's today's learning outcomes. And the term ionizing, ultraviolet, X-rays and gamma, we need to be aware of each of those and their meanings, the uses of each of these and the dangers. It's quite important that we can understand how ionizing radiation can damage cells. So today's work can be found on page 151 to 152 of the Caboodle textbook, which you've all got access to online. And yeah, you can access that online. So 1 to 5 in your margin, just for a quick heads up. And pause the slide now and answer the following 5 questions. So number 1, what are the 2 types of electromagnetic wave transmit communications through optic fibres? Light and infrared. Number 2, give the order of the waves in the electromagnetic spectrum, starting with the one with the longest wavelength. So there we are. Radio, micro, infra, visible, ultra, X-ray, gamma. Okay, remember to make up a mnemonic that you can remember those, but you do need to recall them in order. It's often worth like 4 marks in an exam, so it is worth learning those. Number 3, what type of electromagnetic wave is used for satellite TV signals? Microwaves. What is the equation for wave speed? Keeps coming up time and again. So this time, wave speed equals frequency times wavelength. 2 uses of infrared radiation and 1 danger. Uses: remote controls, fibre optic communication, infrared scanners, heaters, cookers, night vision, cameras. And dangers are heat internal parts of the body and can cause skin burns. Okay, let's get on with today's work. So what you're going to do, again, you can either copy the table or you can print off the table that I have added as part of today's lesson. What I want you to do is print off the table or copy it, but make sure you leave loads of space in each of the boxes. We often get asked in exams to compare and contrast, especially for those aiming for sort of a 4 or above. They want you to be able to pull out those key pieces of information about the uses, the dangers, and the penetrating power of each of these activities. So what I have done for this activity is I've saved in the shared area, I've saved each of the slides so that you've got them. What you're going to do is extract that information from each of the 3 slides, and you're going to fill out the boxes. So you're going to take the slide for ultraviolet radiation and you're going to fill out the uses, the dangers and the penetrating power. You're then going to take the slide for X-rays and fill out again the uses, the dangers and the penetrating power. And lastly, you're going to do exactly the same for gamma and uses, dangers, penetrating power. So I thought it would be useful for you to be able to look at those 4 slides plus have the table that you can break down. And by then completing the table, you can then compare those more accurately rather than just writing down information. I'm going to go through the next couple of slides. I'm going to give you sort of 20 seconds on each slide so you can see them and freeze them if you want to do it that way, if you haven't got the ability to print. But remember, I'm going to tell you that this is the slide and pause now, and you can pause the YouTube video then. Here we go. So this is UV radiation. So pause the slide now if you aren't printing it off to use, so that you can use this information to complete the table. And there's some more on UV radiation. And then we've got gamma rays. So pause the slide. Notice the safety symbols also on this one. a little bit more on gamma rays. Please note that gamma rays aren't blue. It's not a Spider-Man movie. Lastly, X-ray radiation. So pause the slide. And this bit is particularly pertinent. One of the things they often ask you how to do in an exam is how do we measure ionizing radiation? So please pause the slide. And now what I'm going to show you is the notes that you should have obtained from each of the slides. Pause the slide now and can fill in the pieces of information that you didn't get. I'm not going to read this out to you. Please note the bits in red are the protection, okay? So the dangers are in black in the middle column and the protection is in red. So just quickly check what you've understood. Answer the following 3 questions for me. So, why are gamma rays and X-rays more dangerous than microwaves? And what material is stopping gamma and X-rays? Gamma and X-rays are for shorter wavelengths than microwaves, therefore they carry more energy. Gamma and X-rays can be stopped by thick lead. Describe how gamma rays are used to treat cancerous tumours and explain why they're considered to be safe for the patient. They use a narrow beam, and we are talking incredibly narrow, from a radioactive source, usually cobalt-60, and it's directed at the tumour. The beam is aimed from different directions to damage the DNA in the tumour, but not the surrounding tissue. Okay. Lastly, explain how gamma rays are produced. Gamma rays are produced by a radioactive substance that has an unstable nuclei, and they release energy during the process of nuclear decay. So, today, the key points, 5 of them. If you haven't already got them, write them down for me. Right, see you tomorrow, guys.